Now let's discuss the fates of cholesterol in the body. Now most of the biosynthesis of cholesterol happens in the liver. However, some organs are also able to biosynthesize your cholesterol, such as the gut or your intestinal epithelium, the adrenal cortex, the gonads, as well as the placenta. Now, a small portion of the cholesterol are utilized for the hepatic membrane, whereas majority of the cholesterol that's biosynthesized in the body is secreted. It is secreted either as cholesterol esters, as biliary cholesterol, or as bile acids. The production of cholesterol esters or cholesterol esters is catalyzed by ACAT. It stands for acyl-CoA, cholesterol acyl transferase. Cholesterol acyl transferase. So from the name itself, it catalyzes the transfer of fatty acid from coenzyme A, transferring it to the 3-hydroxyl group of cholesterol. The cholesterol esters are more lipophilic versus their free cholesterol counterpart. Now, these cholesterol esters are packaged as VLDL, which is then transported into tissues where they are needed. So, in these tissues, they are either utilized for, number 1, membrane synthesis. Number 2, steroid hormone biosynthesis. Or they can also be utilized for the synthesis of vitamin D. Now, any excess cholesterol esters or cholesterol are stored in the liver. Furthermore, free cholesterol can also be transported in the gut lumen. So, the free cholesterol can also be transported into the gut lumen via the biliary tract, which this free cholesterol actually constitutes the intestinal pool of cholesterol. Now, the hepatic cholesterol pool, yung bumabalik sa liver or yung sinastore natin sa liver, hepatic cholesterol pool, is the source of cholesterol for the biosynthesis of bile acids. Now, let's start with the biosynthesis of bile acids. The biosynthesis of bile acids need cholesterol, your cytochrome P450 enzyme, your NADPH, and molecular oxygen. Now, the conversion of cholesterol to your 7-alpha hydroxycholesterol is the rate-limiting step in the biosynthesis of your bile acids. This reaction is catalyzed by 7-alpha hydroxylase. The activity of 7-alpha hydroxylase is inhibited by the presence of bile acids. So, bumababa yung activity ng 7-alpha hydroxylase kapag dumadami yung bile acids. Now, your 7-alpha hydroxycholesterol can be converted into your bile acids, quinocolic acid and cholic acid. Now, the pH of the intestinal lumen is 6 and the pK values of these bile acids equals 6. Hence, at any given time, 50% of the bile acids exist in the protonated and 50% exists as deprotonated. Now, this deprotonated form is the precursor of your bile salts. Bile acids can be activated using your ATP and your coenzyme A, forming the coenzyme A conjugate. Now, once activated, it can be reacted with either taurine or glycine to form your bile salt. So, these are your bile salts. Kung mapapansin ninyo, the pK values are lower versus the pH of the lumen, intestinal lumen, which is 6. Hence, they are deprotonated most of the time. And anong significance nito? Ang significance nito is that they can act as effective emulsifiers kasi nagkakaroon ka ng charge, hence polar, aside from the hydroxyl groups, and you also have the non-polar components, and that make them effective emulsifiers, having the polar end and the non-polar component. The following diagram shows us the enterohepatic circulation. Your bile acids are synthesized from cholesterol in the liver and then stored in the gallbladder. And then when you ingest a meal, that's when the gallbladder releases the bile acids and bile salts into the intestine. So when the food reaches the intestine, that's when the gallbladder releases its contents. So it's utilized for the emulsification of fats in the diet so that we can absorb them efficiently. Now, this process, the enterohepatic circulation, is a very efficient process because only less than 5% of the bile salts are excreted in the feces. And actually, this excretion is the major route of disposal of your cholesterol in the body, since your cholesterol cannot be metabolized into carbon dioxide and water. Your bile salts are deconjugated by intestinal bacteria, which makes them less soluble. So once deconjugated, we form your secondary bile acids, which are, as what we've already mentioned, less soluble. So their fate is actually through excretion, and they can also be transported back to the liver, where they are conjugated again but not hydroxylated. And then paulit-ulit lang yung process.